Hey everybody, hope you're doing well. This video is going to walk you through the second section of Unit 6, which is going to deal with how to interpret stem and leaf plots. So this is going to be what we'll do for the majority of the chapter here, now that we've reviewed some basic data analysis with mean, median, mode, and all that stuff. Now we're going to look at some data displays. I'm not going to go over all of them. I'm just going to go over some of the more frequently used ones and talk you through a few examples here. So stem and leaf plots, as you know, it's when you have a whole bunch of data points. It's a way to organize them in some sort of way rather than just having a huge list. So you can see here on the screen, there's a stem and leaf plot of student heart rates after doing 1 minute of jumping jacks. So there's a lot of data points. This is a way to sort them in a way that's a little bit more condensed. So just as a very quick review here, stem and leaf, the leaf always consists of the final digit of the number. Typically it's the ones digit of your number if you're using place value. The stem would be all the other digits that come before it. So tens digits, the hundreds digit, etc. So you can see at the bottom here there's a key where it says 6 line 1. What that means is if you have a stem of 6 and a line of 1, you read that as the number 61. One thing that's important to note is a stem and leaf, typically the stems will go numerically in order even if there is no data. So for example, you see the 7 in the stem column, but there's no leaves. That does not mean there's a number 70. If there was a 70, there would have to be a 0 there. If there are no leaves with that stem, that means there's nothing in the 70s that exists. Same with the hundreds. So that is something just to keep in mind, especially when you're doing these on the IXLs. Don't make up numbers that aren't there. If the leaf row is blank, that means there is no stem that goes with it. So we're going to look at a couple of examples here, do some basic interpretation, and talk about some key points here. So you've got your stem and leaf plot. Question A says, which of the following expressions is true? So option A is mean is greater than median. Second option is mean is equal to the median, or the third, mean is less than median. Well, it looks like we're going to have to find both the mean and median and figure out then which is true. So to find the mean, this would take a couple of minutes here. If you're asked to do this on the IXLs, it won't be a stem and leaf that has this many data points, but to find the mean, you'd have to add up all the different values. So you'd have to add up 61, 84, 86, 88, 92, all the 99s, and so on and so forth, till you get your sum. So to find the mean, the sum of all the values is actually 2,410 divided by the amount of values. Easiest way to find the number of values that you have, just count the leaves, because that'll tell you how many different data points that you have. There are 21 leaves. Say I have 21 data points. 2,410 divided by 21 comes out to 114.76. So that's my mean. My median is still the middle number of the data set, and this is in order. So visually, if you're trying to figure out, well, where's the middle, cross off the lowest and highest, next lowest, next highest, and just kind of work your way that way. If you need the visual, cross them out as you go. So you can see here, I am just doing that. And I come across my median. That leaf of 1 has a stem of 12. That means the median is 121. So which of those three statements, the mean is lower than the median? So C would be the correct answer. Part B says find the mode or modes of the data. So I'm going to clear that off so I can have a better look at it. Easiest way to find the mode, find where you have a leaf row that has the most of the same kind. So I can see in 2 places here, I see 3 9s with the stem of 9. So I have 3 99s. I have 2 4s with the stem of 12. So I have 2 124s. Again, I need the most. So 124, there's 2 of them, but 99, there's 3 of them. Since there's 3 99s, that would be my mode, and that would be my answer. So again, it's not just that things repeat multiple times, it has to be the most repetitive. Part C, what is the lowest heart rate? Well, all you got to do is find the lowest value. The lowest value is at the very top of the chart, stem of 6, leaf of 1, 61. In which interval did most of the heart rates fall? So what I'm looking for there is the row that has the most leaves. The one that has the most leaves is in the row with the stem of 12. So if I have a stem of 12, the interval that represents is all the numbers between 120 and 129. So if you get asked the question, what interval? Again, take that stem. Basically, what are all the numbers between that start with a 12? It'd be 120, 121, 122, etc. It's not asking what the values are. It's just looking for the interval that has the most. Find the row that does, and that's how you would interpret that. Question E, how many students were in the class? We kind of already answered this in the beginning. All it's asking for is how many data points you have. We already answered that in a sense when we tried to find the mean. There were 21 leaves. That means there are 21 students. And F, how many students had heart rates lower than 90 beats per minute? So if I want lower than 90 beats, I'm looking at the stems below 90. So stems of 6, 7, and 8. I have 4 leaves, 61, 84, 86, 88. Those 4 numbers are the only ones lower than 90. So that means I have 4 students with heart rates lower than 90 beats per minute. So again, these are the types of questions that when you do the IXLs, the interpretation piece, this is the type of stuff you're going to see here. So it's not about making the stem and leaf, it's about being able to read it. Let me take a look at one more example here. This is called a back-to-back stem and leaf plot, where this allows you to compare similar data, but in 2 different groups. So if you look at this here, if you have a back-to-back stem and leaf plot, the middle column is the stems. So we see stems of 5, 6, 7, 8. So 50, 60, 70, 80, and such. When you read this, you always read from the stem first. So if I'm looking at this here, if I'm trying to read the 9th grade numbers, I'm reading backwards here. So stem of 5 and a leaf of 5 would be 55. A stem of 6 and a leaf of 5, 65, 67, 73, 74, 77, and then all the numbers in the 80s, 81, 83, 83, 85, 86. Obviously, it's a lot easier to read the left to right, so when I read the 10th grade ones, that will be exactly the same as what you saw on the first slide. But again, this is just a way to compare 2 large sets of data, organize everything, and allow you to compare things in a pretty easy to read format. So let's go ahead here and answer these 3 questions. A is asking, what is the median of the 9th grade fundraiser sales? So if I look here, I have a total of 11 leaves, so I should have a pure middle. So again, I can cross out lowest and highest as I go along. And there is my pure middle left over. Leaf of 7, stem of 7. The median of the 9th grade fundraiser sales would be 77. What is the range of 10th grade fundraiser sales? Range means highest minus lowest. The highest number on the 10th grade side is 83. The lowest number is 66. Again, like I pointed out before, if you have a stem with no leaves, that does not mean that's magically a 50. There would have to be a 0 in that leaf row in order for that number to exist. Since there's nothing here, that means there's nothing in the 50s. The lowest number would be 66. So again, to find the range, I subtract those 2 numbers. The range would be 17. Now, last but not least, everyone's favorite part here, finding the mean. So we go ahead, and once again, you want to take your time in entering all the numbers. So again, as I went through on the 9th grade side, make sure you're reading it from right to left, always reading the stem first. And then you can add in all the 10th grade numbers, like I'm doing now here in live time. So if you add all that up, you end up with a sum of 1,563. We have 11 data points, 11 leaves on the 9th grade side. On the 10th grade side, there are 10 leaves, so combined we have 21 data points. So we take that and divide it. The mean would be rounded 74.43. When you're doing these here as part of your IXL assignment, again, read carefully what it's asking you to find. It's going to probably flip around a lot between mean, median, mode, and range. So again, make sure that you're paying attention and not finding the wrong value and then constantly having to redo these. It's about the only mistake I ever see people make with this. But again, this all just falls in line with the math that you reviewed in the last lesson regarding how to find all these different data points, if you will. So, IXL, again, we are in level I. The IXL that goes with this particular topic is BB5. Get it to an 80, again, basic interpretation of similar stem and leaf plots like I just showed you in the last two examples. As always, if you have any questions, feel free to send me a message on Schoology, shoot me an email, or stop by my office hours on Zoom. Otherwise, thanks for watching, stay safe, stay healthy, and we'll see you next time.